Hey, welcome to the show, guys. How's it going out there? Been a rush so far. So this is bound to be a rush. If you'd like to support this channel, there are PayPal and Patreon links in the info box below. Let's see who we got on the panel. Hello out there. Nathan, sir, I see you there. How's it going, sir?
Well, very well indeed. How are you?
Good. Radio check. 1 2 1 2 1 2.
Adam's just letting the dog in. We've got Arwin as well. Hey, Arwin.
Hey, hello, guys. Yeah, coming through loud and clear.
You're a little low, but I got you guys are a little low. I got you.
Right,
I got you.
I'll get
Adam,
closer
sir.
to the mic.
Evening, guys.
Wow,
Sorry.
you're high.
Is that better if I sit back a bit? Move
Yes.
it away.
Perfect. Thank you.
Oh. Evening. Sorry, I've just been chasing the dog around the garden.
You won't believe. I'm lucky I'm even here. I made it, man. Unbelievable, right? It was boring all morning until about 20 minutes before the show, and then everything started. Phone started going off. I had to go across town, right? I said, oh, man, this isn't going to turn out well. I know it's not, right? So I'm cruising across town, and the red lights. Let me just tell you something. If anarchy ever ensues, the red light, they're the first to go. They're the first casualties. I don't care. They're finished. If you're ever around this area, just forget about the red lights because they're going out first.
Now, that's just Murphy's Law, John.
But everything turned out really good, man. I made it across town. I took a couple shortcuts, and it turned out well for me. And then I took the same shortcut back. And there was some traffic. I was getting a little concerned, and of course the lights. And then I get behind Grandpa Jones. I couldn't believe it. I'm sitting there. Wait, it's 45. This guy's going 25. I'm sitting there with that, and then I pull off to the left a little bit so I could see if there's anyone in front of him. Clear sailing. There's nobody in front of him. He's going 25. I laid on the horn one time on him and said, what? Come on, at least do the speed limit, right? So I'm lucky because there's a big old straightaway right when this guy got in front of me. So I gave him a little room, and then I said, okay, you're finished, man. Just hit her down. I got about 225 horses, right? I just blew right by him. So that's my story. Didn't get pulled over by cops or anything. How you like that?
It's a great opening story for a Ballbuster show. Just truly awesome.
I'm like that on my bicycle all the time. Everybody goes too slow for me.
Let's see if everyone liked it.
I'm an expert at catching up and all that. So.
Give me a thumbs up out there if you like that intro story.
Would that intro have been possible on a ball?
How does it work on a ball?
Yeah.
I don't know. I don't think so.
But then you would have to correct for Coriolis deviation constantly in the car, like that one guy that claimed it. Remember?
Yeah, if you overtake and you're not in the same reference frame, yeah, he might have just maintained it. So probably wouldn't have worked on a ball.
Okay.
Are you pausing
Looking
to
good.
start
We're looking
launching into a Coriolis? Is that what you paused for?
Say again, sir? A little low.
Has that been paused for me to launch into a tribe about Coriolis? Because it's not going to happen.
Yeah, they're trying to bait you.
Actually.
Yeah, they are.
I don't remember who the guy was, but I remember that at some hangout somewhere, some baller claimed that his car was actually had to correct for Coriolis deviation. Like constantly keeping on the wheel.
That's just stupid.
He really believed it. I think it was on Jose's or something.
Now that makes sense.
Right.
You guys had a question from Simon Dan sent to you by email?
No.
I was chatting with David Weiss earlier, and he brought up Simon Dan in his conversation. And I said, oh, that's a funny coincidence. You should bring up Simon Dunn. He sent me an email this morning, just out of the blue. And David was like, yeah, me too. So we swapped and compared emails that Simon Dunn had sent us. Would you like to hear them?
Yeah, go ahead.
Hi, Nathan. Student measured the frequency of a water wave as 5 hertz. Calculate the period of the water waves. You have 24 hours. Want to hear the one he sent to Dave Weiss?
Good.
Hi, David. A car has a mass of 750 kilograms. How is the kinetic energy of the car calculated when the car is traveling 8 meters per second? You have 24 hours. Would you like to hear my reply?
Okay. Oh,
Yes, Nathan, we'd love to.
Yes, Nathan.
Oh, go.
go.
Dear globe-worshipping wanker, measure R. You have the rest of your natural-born life. Good luck with that. My question will change your world. I ask it daily, along with a few others you can't answer. Is, quote, they're just wrong, your final answer on the second law of thermodynamics versus space, or did you need another lifeline?
Nice.
Oh, hold on. I got one. But this was June 8th. This was right after the numpty clip came out on him. So here you go. Hi, John. A crate on a crane weighs 11,500 newtons and is lifted vertically 2.6 meters. Calculate the work done to lift the crate. You have 24 hours. My response, piss off, booger eater. You can't recover, son. You have 24 hours.
What's going off?
I don't know,
Trying to get him to
man.
do his homework or something.
I don't know.
I don't know.
It's really weird.
Just a bunch of gamma rage.
Trying to catch flat earthers out in a gotcha question, and he's been caught out in questions that are paradigm changing. He's asking basic physics questions. Don't really get it.
It's pretty desperate, is what I read from that, mate. I've got nowhere to go with regard to the shape of the Earth to catch up, so I'm just going to throw random questions at you, like a pub quiz.
Cycles per second be a physics question or a maths question?
Math.
Relating to Hertz, so it's physics.
They're all mathematics questions. They're not physics questions.
I thought
You
it was a
gotta
math.
realize though how they think, how a lot of these people think, you know. They're not trying to convince us, they're trying to convince their own. So we won't fall for that shit.
What, the 10 to 14-year-olds?
Them will.
Yeah,
You know,
he's got 10 to 14-year-olds. That's his target audience. That's who he has. So, I don't know. Sci-fi scam, you can't recover, son. You're already numpty clipped. It's over for you. I mean, that was a tear-jerking belly laugher. You should have heard how many people commented to me personally on that one. They loved it. You're finished.
Does the energy of cars and cycles per second, or newtons begging the question, these are maths questions. The title is physics question. That's what the title of the email was. Same for Dave. Presumably same for you. Title physics question.
Hold on.
It's maths. Number of cycles per second. That's maths.
Well, the answer he's after is just pure mathematics. There's no, isn't it? It's just the calculation he's asking you to perform. It's physics in that it's a physical wave he's talking about, but actually what he's testing you on is maths, yeah.
No, mine was not introduced with physics. It just said, hi, John. That's it.
Yeah. Like I say, the pertinent nature of the question is what's relevant to me in terms of when we're asking him, how can you have gas pressure without a container? And he's asking a BBC physicist for the answer. That's relevant to the nature of existence. How many cycles of a 5 hertz wave isn't paradigm changing in any way, shape, or form?
I want questions, right? I was bored this afternoon, right? I've got it in front of me on this paper, right? There was a question on YouTube, like, a maths question. I've spent like half an hour or so just working that out. So, Simon, Dan, send me one. I'll give you one, Dan. It's the one I did this afternoon, right? Alice and Bob take 2 hours to do a job. Alice and Charlie take 3 hours to do the same job. Bob and Charlie take 4 hours to do the same job. How long does it take all three of them to do the same job? Quite a good question. Like I say, it took me about half an hour or so.
Yes.
Maths question again.
So I'll have maths questions off Simon Dan, please, because I find them entertaining, as sad as that may sound.
Can you ask the question again? At the end, say, you have 24 hours.
Okay, yeah. Simon Dan. Alice and Bob take 2 hours to do a job. Alice and Charlie take 3 hours to do that same job. Bob and Charlie take 4 hours to do that job. How long does it take Alice, Bob, and Charlie to do that job? You have 24 hours to reply.
Disclaimer. This question will not change your worldview on anything at all.
Just to let you know, I've been hammering ball-tards with the stationary drone, inertial reference frame, moon and star rotation. It's just crushing them, man. Crushing. Just to let everyone know, it's a bloodbath out there.
How are the numpty clips doing?
Really good. I am so thoroughly enjoying. I enjoy doing them. I really do. Keeps me sharp, right? And I'm backlogged, so it's I don't. It seems like I'm never gonna get to the end.
I've not had any new name requests in a while, actually, John. So it's but you've got a nice catalogue of all the usual suspects.
The usual suspects. I got a pretty good catalog. Yes. Yep. Numpty clips are going good. Every Monday, Wednesday, and Thursday, 2 p.m. Central, 7 p.m. I screwed that all up. The Numpty clips be there. 2 p.m. every Monday, Wednesday, and Thursday. U.S. Central and 8 p.m. UK. Did I get that right?
Yeah, you did. I've put together a playlist as well. So while I was discussing stuff with DITRH, he suggested that I put together a playlist with short videos, i.e. to the point, concise. As he said, have you got some clips that are shorter? And I'm like, by pure coincidence, I have actually just spent the last few months making lots and lots and lots of very short, maybe 1 to 3 minute clips. I've put those together, and it's been called the Dearth List. That's now on Nathan Oakley 1918. It's just a playlist with, it's up to 70, maybe 71 videos that are all less than 3 minutes long. So shout out to DITRH, as it was his suggestion to do so. It's not the same, obviously, because numpty clips are very beginning, middle, and end with a point. These aren't. These are just debating sections, little debating points that have been made, that have been trimmed down to the most precise 3 minute section of that particular debating point. That's on something called the Dearth List, which is on Nathan Oakley 1980, as we're shouting out video playlists that we're making. But yeah, listening back, put it together, listen back to it, and I'm chuckling away. It's good.
You're going to get some links to his app with those ones. Links certain videos.
Discussion was for. That was exactly right. Yeah, that's why he was asking me. So I'm hoping he's going to do exactly that and stick it in his app. Well, that was his suggestion why the playlist might be necessary.
Oh.
Hey, Whiskey Shaw, man, shout out, man. Thank you for all the hard work. Yeah, thank you. You're welcome.
Everyone needs a good Oh, sorry.
I was just going to ask what other news has been over the last couple of weeks since we last did the BALLBUSTERS. Not a lot for me. I've spent most of it in bed, and today for that matter.
How's your
Still not well?
How's your toofus?
Actually, my tooth, but yeah, my face is all right. 90% better. I'm still ill.
Milk it, Nave. There won't be long left. Keep it.
Milk it.
My tooth is actually a bit playing up again as well. So
I feel a need for pain meds coming on.
So the pain of stress is a lot less for me thanks to the amount of support I had doing a GoFundMe campaign between the last Ballbusters and now. So the exhaust went down, go boom boom on my car. And a couple of commenters, that was quite amusing, were like, oh yeah, when the exhaust rotted and fell off your car, why didn't it go up? I'm like, what, like out of it?
brilliant.
Yeah, that's now fixed, which is a definite relief. Because it's the cause of a lot of stress when you can't afford to do things. And that was the cause of a lot of stress for me. But thanks to the supporters that I've got, thank you very much indeed. That's relieved a lot of stress. It was literally making me ill. You know, too much work, but that's my own doing, not necessarily the fault of my rather knackered 15-year-old car. Not knackered anymore, though. Thank you very much to all the people who supported my GoFundMe. I really, really appreciate it. Any other news? Anybody else got anything that happened with interesting back and forths with ballers? Anything of that sort of nature?
Well, my chat has been pretty interesting, I think, in the last week. A lot of conflict rising up. It's kind of almost like back and forth at other platforms, except I'm the only one that has any verbal capability. But they are allowed some room in chat, you know, even if they get off the rails. As long as it's temporary, well, I give them some room to express themselves. And it's been pretty interesting from the baller side as well. But yeah, in a way, they know they're defeated. They know.
Get a different Arwin on your show. So if you tune into Flat Earth Debate and see Arwin on Flat Earth Debate, you get to see Baldwin. It's like our devil's advocate at the moment, just the way things happen to have positioned themselves. And Arwin's very good at it, I'm not going to lie. He's very good at being a baller and, you know, highlighting the tactics they use and then stopping short of getting irritating and doing it indefinitely, like round and round, circle jerk, etc. On your show, I mean, I listen to your show almost every day. I don't necessarily sit in front of it and watch the chat, but obviously because you're interacting with the chat, I get a pretty good idea of what's going on in the chat. And you're always 100% on flat earth point. You know the arguments well enough to play him as devil's advocate, therefore you're obviously going to be a good defender of the point from our side when you are actually doing that. It's like listening to a different person. Interacting with you on my show is very different to listening to you do your own show.
Right, yeah, Baldwin, you know, it's kind of a problem because, to be fair, I'm a little bit addicted to being like that. It's baller addiction. I never was able to really permanently get rid of it. And that's also why I have the idea of the dual cosmogonical society. It's really like, come on, man. Let's just exploit these concepts, these fantasies to the maximum. Because there's so many dynamics that have come out of just this duality situation. And I just want to get the maximum potential out of it.
It's good fun being Baldwin. On the very rare occasion that I've played devil's advocate for the globe position against someone, i.e. it's not just me highlighting the point in a funny voice to get the point across, it's me actually interacting with one of you guys playing Flat Earth or being Flat Earth proponent and me being the glober. It's fun. And the reason it's fun is because the standards are very different on the ball side, and the tactics you can employ and get away with are very different on the ball side. You can employ a lot more fallacy and just circle jerk if somebody calls you on it. It's just fun. You know, having the standard where even if the standard's so... I'm going to put this to QE, sorry, Arwin, but you'll know exactly what I'm talking about. When the standard is so skewed, you can literally say something that is downright wrong, not only downright wrong, but downright wrong against your own rhetoric, and people around you on the ball side will pat you on the back and tell you what a good job you've done. That's how skew-if the standards are on the ball side. To use that to your advantage and then argue in that context is actually quite good fun because you can get away with murder. Of course, it's only fun for me and Arwin because we don't have the cognitive pain that goes along with actually holding that belief. So we can just extract the fun of having society on your side.
Well, actually, Nathan, when I do ball win, I do experience cognitive pain. Really. But I have it under control. You know, when it gets too much, I know when to quit. And it's been pretty smooth so far. But I do, yeah, it's really an emulation of what it is to be a baller when I am like that. Right? And that's why it seems so real, because it really is real. But I got it under control.
Like a character actor, you're saying you're so in
It's
character.
method acting.
Yes.
That's the one. That's what I meant.
Well, that's
Method
effectively what I'm doing, yes. And I'm emulating how I actually was 20 years ago, right? That's really what I believed. And it was glorious. Even in the memories, it's like, yeah, you knew it was like, yeah, it's no use, but it was just kind of glorious in some way. And that glory still, after all this time, rubs off. You know, I still get it. Why people get so stuck up on it. Why they put in so much effort. I understand. And yeah, I'm glad I'm able to express it through Baldwin that is allowed to get out of his golden cage every now and then. Because he knows, like, yeah, it's fake. But you can be allowed to forget about that for a while. You know? That's what it's
I
like.
get a bit of grief from my commenters about Baldwin, and I have to explain to them, it's like, be able to do that, to play your opponent's position in the way that Arwin does, or anybody else for that matter, means you've got to know not only your own argument inside out and back to front, you've got to know their argument inside out and back to front to be able to do that well. So it's a skill. You've got to. It's a skill that any good debater should do, which would be to say to play your opponent's position. Someone, not that noise. Get somebody on your Rob. Can you mute, please?
Sorry,
Somebody.
I was. Yeah, sorry.
So if you're trying to hone your debating skills, the way to do it is play your opponent's position. Be your opponent against somebody else who's on your side, and try and argue their position. Hard. Unless you've been doing it as long as Arwin and I, and then it just becomes a laugh, right? Not for Arwin, it's painful apparently, but you know what I mean.
That's only when I'm in the role, you know, then it becomes painful. But when I can step away from that, but it is kind of a switch situation. It's really like a character switch. It's like, okay, now I'm gonna drop it. Sometimes I even need to do it from within the Baldwin character. If some really interesting little thing is being brought up and I need to be my full evolved 20-year later self in order to take care of that, right? Because Baldwin doesn't really know about the depth of the flat earth modeling that I've been attempting over the years. You know, he doesn't understand that. He's just stuck on like, yeah, no, it has to be a ball.
Oh God, you've given him you're literally assigning a third person to him now.
Well, yeah, I guess.
Yeah, I was just going to say that before.
I got it under control. Really.
He's third personing it.
All getting very Dungeons and Dragons.
Yeah, it is. Hey, shout out. Got some super chats. Lumpy gas in a vacuum. Thanks, Huey. You're welcome. Nick Whiteman, Chunky Bear. What is this refraction these ball-tards made up for the Black Swan? Oh, they made up... we'll get to that. Don't remind me. And shout out Tony Wickham, sir. Nathan thanked me the most for the donation for GoFundMe. Woohoo, he said. That was worth every penny. Laughing out loud. There you go. That's the end of them. Go.
It's got to be sarcasm because he gave me something like £100. So a woohoo, that's definitely not worth 100 quid.
Right.
So I'm guessing sarcasm, but I am genuinely grateful to you. Thank you very much.
Can I fill in some character detail about Baldwin, right? Myself 20 years ago. I would like to remind you guys and everybody else that as Baldwin, you know, the alternative of when I now emulate him and I phase out back to myself, that's really comfortable. Back then, I would be defeated at times and I would get really depressed, right? I was kind of like manic depressing in those days because I took it so serious and didn't understand what I was actually doing. I really believed it. I believed in the mission. I believed in the reification, basically. It's really bizarre how that works. But
Totally
yeah,
right.
when you are then actually defeated, confronted with facts you can't handle, it's really painful. You really fall down and stumble down and are like in the darkness, like, what is going on? How can this be? You know? And we as flat earthers, we're so used to now being over that, we underestimate sometimes how much impact that can make. But because of my emulation, I can still experience that.
Well, maybe by emulation, but I don't underestimate it. That's why I say share your pain. And not only can I relate to what you've just said, I can give you a specific example. It might not be from 20 years ago, but from way back when I was a baller. That feeling you've described as I used to say is a sort of empty feeling I got when watching Science at NASA videos. Science at NASA is the NASA channel on YouTube. And every time I'd watch it, as a heliocentrist, I'd see the little disclaimers on the video footage that was actually CGI. You know, it would say like dramatization or actual footage, or it'd have a little disclaimer that would make it clear that you were watching something that was just presenting itself as being what would happen on Mars when they land on it, for example. I remember them showing those footage that we now see from the Mars landing, the same footage that is showed 10 years ago on Science at NASA, how the mission would evolve. It's the same exact CGI. Now, people who are watching it may not realise that, but it's the same exact stuff. Obviously, they can't film, even if we did live in a sky vacuum and they could travel through it and land there with helicopters and parachutes or whatever they're doing on this particular occasion. Even if all that was actually true, they can't film it, right? They're not sending a second craft to film from a third position. So what are you going to do? Just going to CGI it into existence and say this is how it would look if we were to film it, and just disclaim it. Well, that used to leave me feeling quite depressed. You know, well, why not? Why can't you film it? Isn't that the whole point? How are you supposed to prove it's even happened? I used to think. But there we go. Obviously, you know, their disclaimers are that they can't really do it. You know, it's just too tricky. And that would make me feel a bit depressed. Now I just laugh at it.
Right. Well, on my
Not
own,
depressed, but
this stuff doesn't make any impact anymore, really. I've been through it. It's just kind of like a reenactment. But it's fascinating. I'm learning so much from this calm position, so much more than I did back then. I went through it back then, but now I'm learning so much about it because I'm just much more calm.
Did you, Adam? Did you want to add, Adam?
I was saying not so much that, more confused or frustrated, and possibly starting to smell something is awry. Is when I looked at those sorts of points. It's nonsensical. You can do all these things, but not transitions and stuff. There were more, not necessarily red flags later on, early on, but they become that. But I say early on, probably more points of frustration or confusion as to why you're giving me this rhetoric. It's not actually, well, it's nonsensical, the excuse you're giving me.
Yeah, I described it as an empty feeling that you were left afterwards, because you kind of go into a Science at NASA video thinking, this will explain something about the nature of my reality. But at the end of it, you end up thinking, left me with more questions than answers, and a very unsatisfied feeling about what you have actually told me. You haven't proven it to me. Even at an unconscious level, I think most people are aware of that.
Unconscious or subconscious?
The subconscious level, my bad. At a sleep level.
I love it when people do. I'm sorry you did it.
At a subconscious level, you're aware of it. And you just shove it to the back of your mind. And then when you come to defend it against people like us, it'll express itself as actual pain. It's bringing us to the end of this conversation, probably. Well,
Yes.
I asked them to share that pain in the comments.
Yeah. We coming to the end.
I think so.
Arwen, did you get all your 10,000 words at?
Maybe. We'll find out.
That's really scary, referring to yourself. I want to say self, the one you conjured, and the third person. That's pretty scary.
That's acting for you.
Ah,
I'm an
I gotcha.
actor. Actor.
So, you want to have some other people share their pain, especially over spectroscopy? Is that what you guys were thinking?
Yeah, spectroscopy. That's a wonderful subject.
Spectrochocoloscopy.
He got it out before I did. Yeah. Chocolate. Shout out to Chocolate, wherever you're at. Yeah, this one, like I said, is enjoyable for me because every once in a while, it's a 4 to 6 month time frame where I put this presentation out, right, and then you don't hear too much about what the sun is made of, and then it starts to come back right in that 4 to 6 month time frame. I was hearing little things about it here and there, and I said, okay, it's about that time, so that's why I decided to do it. I enjoy the presentation. Because they don't know what it is. In fact, most can't even pronounce it correctly. Right? So it's a lot of fun. Hope you guys enjoy it out there. I guess we can get on with it. Any objections?
No, not at all. Spectroscopy, let's do it.
Go, go, go.
You want me to stop a couple times in there? Just trudge my way through it.
I just ask, what is spectroscopy?
It's a reification.
There you go.
No, it's not.
It's
Not a reification.
It's a reification.
When you apply to heavenly bodies, it
I was going to
is.
say terrestrial or celestial.
Exactly. Go ahead. Answer who asked the question. What is spectroscopy?
The analysis of light.
Not you.
Oh,
Well,
sorry.
Well, I asked the question, so I shouldn't be giving the answer.
Well, you did you hear Adam's response? Adam, say it one more time.
I asked whether it was terrestrial or celestial spectroscopy you're referring to.
Both, because I have no idea what it is in the first place.
They're different answers, and to both scenarios. So, and I think John's presentation will answer it.
Yep, we're gonna get to
distinguishment.
We're gonna get to it directly right now. How about that?
That's good.
So, do you guys want me to stop, like I said, or trudge through?
Stop so we can interact.
Okay. All right. So we got her up on there. You know what? I'm not sharing. Do I want to do that? Last time I did that, I overheated and shut down. Oh. Your call.
You're asking if we should have it shared in Discord. I don't care. I don't mind if you don't.
Okay. Yeah, I'm not going to do it this time. All right. Everyone's seeing it out there, so we're good to go. So spectroscopy. He asked for the definition. Generally, it's basically the interaction of light with matter, specifically with respect to emission and absorption of radiation. Basically, that's what it is, right? The entire enterprise is based on the quantization of energy. That is quantum mechanics. I'm going to show you that in spades here. It's real easy. Each element has its own unique, distinct fingerprint governed by the number of electrons and their respective shells or energy levels. Better to say energy levels. I know I have this diagram here. It looks like the electrons out here orbiting. Listen, don't worry about that. There is no orbiting out there in atoms. Don't worry about that. It's just used for demonstration purposes. Okay? So what this is showing is every atom absorbs energy. It these electrons kick up into higher energy levels. But their goal, along with my goal, is to endeavor to persevere to be in the ground state. That's the most relaxed state, right? Even if we want to run a marathon, we go ahead and run the 50K marathon. Good luck with that, by the way. You have to stop at some point and rest. So that's what atoms like to be. They like to be in their ground state or the rest state. Okay? So this shows you more or less what happens and really drove home the efficacy and the veracity of quantum mechanics, because you can't get around this little one right here. And it's called the quantum leap. So as you see in the depiction over here, this is simple. I don't think it's hydrogen, right? Yeah, whatever. It doesn't matter. What happens is when you heat these monkeys up, like I said, the electrons kick up into higher energy levels. Now, on their way back down to the ground state, see, this is the kicker. You see this space in between here, in between these energy levels coming back to the ground state? The electrons don't pass between these spaces. They're here, and then boom, they're here. Quantum leap. Then boom, they're here. And then you say, you're out your mind. You don't know that. Yeah, we do. You see this little monkey down here? Right? If that wasn't the case, folks, if that electron traversed the space in between back down to the ground state, what would happen here is you'd get a smear. This would be a rainbow, right? But it's not. There's discrete energy levels being emitted here. That's it. That's how simple it is. Any questions on that? Let's make, because this is pretty important. I don't want to drop anchor here for too long, but it is pretty cool. Any questions quickly?
Well, I'm just assuming you've got the three, I'm going to call it digital, just for want of a better word, lines.
Yes.
What you've got on screen. Yeah. So when you say there's a smear, just simplistic terminology, it would mean that there would be a transition period. So if you imagine the second hand on a clock, there's an in-between number 1 and number 2. As it moves from 1 to 2, there's an in-between. It's analog. In the case of what I think is on screen now, you can see 3 distinct lines. It's jumped from one to the next, and then to the next. There's no in-between.
Yep. You understand this? You've got, I would say, a good 50-60% of quantum mechanics.
If you understand that, don't you just go, oh boy.
Yep, that's what you do. And then your next question may be why or how. I'm sorry, I don't have the answers to those questions. And no one does. It just is.
It's all about wave patterns in frequency ranges. That's how they managed to perfect it.
Yeah, it's really cool. And gives a lot of veracity to spectroscopy. That is terrestrial spectroscopy. We're gonna be talking about that over the next few minutes. But let's lay some more framework or groundwork. There are 3 main types of spectra. This is very important. Continuous, that's the top guy. Emission and absorption spectra. Emission and absorption are just flip sides of the same coin. Continuous spectra are produced, very important, by energized solids. And the reason why you get this smear right here in an energized solid is that when you heat up a material, those atoms start to move really fast. And what happens is they're spectrum smears, like I was talking about above, right? So you're not going to get anything right here in absorption and emission spectrum. It's just going to be a continuous spectrum, okay? Now, like I said, this is produced by energized solids. Plasma also, however, with caveats with the plasma. That plasma got to be in a container. The solid doesn't. The plasma does. Hope everyone understands that. Then the emission lines, they are produced by energized thin gases. And a caveat, without a light source behind them. Very important. And the absorption line spectra are produced by cool, thin gases. Cool, thin gases with a light source behind them. That is very important right there, folks, because that's what we're going to be mainly dealing with here. The absorption line spectra of the sun. Cool. Good. Key learning objective. Gases only emit and absorb in bands. That is, in lines. Let me say that again. Gases only emit and absorb in bands or lines. Very important.
Are those straight or curved?
They're straight lines. So, the principles. We have atomic emission spectroscopy. That's AES, and atomic absorption spectroscopy. AAS. This is what is called terrestrial spectroscopy versus astronomical spectroscopy. What they did was they took a highly technical and voracious topic and that just took the name spectroscopy, and just by fiat they knew how would we want to say the increased veracity of spectroscopy is, so they just stole the name and put it right behind their astronomical horsebucky, right? So it could denote the same veracity. I'm going to show you over the next few minutes that this is like comparing apples and orangutan. It's a belly laugher. You're going to see that right quick. So terrestrial spectroscopy, like I said, atomic emission spectroscopy. This is flame. And this is inductively coupled plasma electrothermal graphite furnace. You see this thing, right? It's inside a frigging machine. It's a closed system, highly controlled. I want you to focus on that part. Highly controlled, and obviously it's in a closed system, right? Got it? And like I said, if you want to, I went through this in the first presentation with spectroscopy, talking about the steps that are made with it. Go back to the first presentation. I'm going to skip through that now. Then we have atomic absorption spectroscopy, right? This is a flame atomic absorption spectrometer. Again, we got a machine. It's inside a friggin' machine. It's a closed system. It's highly controlled. And again, the steps and the processes, you can go back to the first presentation to check that out. It's pretty cool. Now, those two, which is terrestrial spectroscopy versus celestial or astronomical spectroscopy. Can you tell the difference? We have an open system here and not controlled. All the unknowns and millions of potential confounding variables between you and the sun. What about the things that you don't know? This is the McMath Pierce Solar Telescope at Kitt Peak National Observatory. This guy is the one that gave you the sun spectrum that you're going to see here in a few minutes. So, of course, everyone sees the problem, right? It's a false comparison, a false equivalence. Right? Actual spectroscopy, AES and AAS, that's a closed system and it's highly controlled. Celestial spectroscopy is an open system and no control whatsoever. These are two different animals, folks. It's self-evident just by what I showed you. I don't have to do anything else. It's another feebly contrived, clumsy Dunning-Kruger bait and switch. That's all it is. All they're doing is an equivocation fallacy with the word spectroscopy. Right? The clowns say spectroscopy using the veracity, like I said, of actual spectroscopy that's terrestrial to give credence to their fairy tale celestial spectroscopy via Elmer-Fudd linguistic association with the word spectroscopy. So, in summary, it's a simple doofus equivocation fallacy and a Mr. Magoo false equivalence fallacy. In total. We want to stop right there for just a few quick.
Yeah, I like to summarize these things for my own benefit, if not the benefit of the audience. So when you're dealing with terrestrial spectroscopy, dealing with a controlled environment, you've got a closed system that is not allowing any other outside influences to affect what you're studying. In other words, when you've got the picture of the box, by whoever manufactured it, they're not worried about what's happening in the lab around the box. because it's isolated. There's nothing happening inside the box that they need to concern themselves with outside the box. However, when you then go to the picture of the telescope, literally a bird could fly in front of that. And anything that's above the layer of what they think is atmosphere, sphere-shaped air, is what you called unknown. In other words, you don't know what you don't know when you're studying everything between you and the sun. You don't know what's between you and the sun, then you haven't factored it in. It's not in any way isolated. It's not controlled. So while the one style of spectroscopy, that would be terrestrial, is isolating their studies so that they can rule out anything else having an influence over what they're studying and therefore their results, with telespectroscopy, they're not.
Anything else? You're correct, Nathan. Yes? Good?
Like I say, just summarising it for my own benefit, so I'm wrapping my head around it as you're saying it. It's basically the same as you're saying.
Yep. All right, number 2, belly laughing train wreck. This is really good. This is from Foucault, Peter, Solar Astrophysics, and the Cool Cosmos from California Institute of Technology. Listen up. Astronomical spectroscopy is used to measure 3 major bands of radiation: visible spectrum, radio, and X-ray. While all spectroscopy looks at specific areas of the spectrum, different methods are required to acquire the signal depending on the frequency. Ozone and molecular oxygen absorb light with wavelengths under 300 nanometers, meaning that X-ray and ultraviolet spectroscopy require the use of what? Satellite telescopes or rocket-mounted detectors. Interesting. Radio signals have much longer wavelengths than optical signals, and we require the use of antennas or radio dishes. Infrared light is absorbed by atmospheric water and carbon dioxide. So while the equipment is similar to that used in optical spectroscopy, satellites are required to record much of the infrared spectrum. Very interesting. Thank you very much. So, since X-ray, ultraviolet, and infrared spectroscopy require satellite and rocket-mounted telescopes, for a very good reason, you're going to see why below, they need to travel into a second law of thermodynamics violation, aka telescopes in Narnia. They're shit-canned. Since our focus is on the sun, radio spectroscopy is also shit-canned. So we could just can these, file 13 them. Section summary. When the incoherent hordes of clinical-level Dunning-Kruger pretender clown wiki discover channel parroting spinning ball-tard space monkey window lickers respond with spectroscopy or spectroscopy or whatever they come up with. When challenged with how do you know what the sun is made of, you can now laugh uncontrollably in their crayon-munching faces. I can really stop right here, but where's the fun in that? Because we're going to get into a party starting now. Remember, key learning objectives.
Okay, but before you start that, can I just ask something real quick? So when I ask somebody what the sun is made of, they're gonna say, "I know because of spectroscopy."
Yes.
I thought we just knew it was a burning ball of hydrogen.
No.
No. How they say
For
that.
fuck's sakes. Sorry for swearing. I'm sorry. What do you mean, man?
No, it's good that you're asking because that's how they.
Well,
say
yeah,
it.
thank you.
There's a bit in there that I think I've overlooked previously. If you listen to what he's just said, he's describing how you build the picture they're going to use to validate this absorption spectra picture. And within what's just been described, it tells you that the only way you can build this picture, as it will be portrayed to you, requires something to be in a second law of thermodynamics violation as a medium. Point is, you can't build the picture then from a terrestrial point of view. That's what the admission in what QE just read is what I heard there.
Who's asking the question?
I think it was a question.
You mean my question?
Oh,
Well,
Rob.
it
Okay,
wasn't-
gotcha.
Yeah. It wasn't really a question. It was, well, I guess kind of was. It's just like, if I look at the sun and I ask somebody, what's that made out of? And they tell me a big ball of hydrogen. How does spectroscopy tell me that?
Well, I just wanted to know who it was so I could turn your mic down.
Oh, yeah, sorry. I got a good mic today. Yeah, normally my mic is shit.
No, before we get off the rails, I'm glad you've said that, Rob, because the audience, they might not realise that, they might not appreciate, well, what's the relevance of this? Why are we discussing stellar spectroscopy? When does this rear its head in terms of your average show's discussion about the nature of the world? And somebody says, see that light up there? That's actually 93 million miles away, burning ball of gas in a second law of thermodynamics violation. Well, how do you know? Well, we've got spectroscopy. They won't say stellar spectroscopy. Correct me if I'm wrong, QE, but also to make the assertions in stellar spectroscopy, they have to have the base of standard spectroscopy to make those assertions in the first place, right? They've got to have the controlled examples to know the details about what they're looking through when they make their exceptions or claim that they've got to travel to a second law of thermodynamics violation.
Yes.
Although you're saying they're hijacking it and it's a bait and switch, it's not the same thing. They still require all the information from actual spectroscopy to make any assertions whatsoever.
Yes. They're using the proof of concept from actual terrestrial spectroscopy to give credence or veracity to their horse puckybolics.
Right. It's a false comparison.
Yeah.
But they are going to use the same terms. They're going to use even the same title
Yes.
to bait and switch you, basically, to swindle you.
Yes, and you're going to see that over the next couple minutes. We're going to talk about exactly what you just said.
Yeah, thank you for clarifying, guys. I wanted to make sure.
Okay.
We're all on point.
Yep.
Did you get the point I was making there, QE?
Go ahead, Ed.
What they're saying is it's going to be made of hydrogen and helium, and we're going to look at this absorption spectra from the full emission, see what's there, and draw a conclusion from it. What you just outlined demonstrates that the only way you can get that full set of data is from, by their admission, you have to go to space at the infrared.
Why would they need to do that?
Well, to substantiate their claim that what they're claiming is, to get all this data. What I'm saying is they can't do that. So
Right.
The data you're presenting that apparently gives you the full thing has to have been falsified, because the bit they're getting the detail from doesn't exist. It's supposedly coming from space. So it was an admission of falsification to me, what I heard there.
Yes.
It's broken in or out of their paradigm, Adam. So if you say, okay, we're going to accept the notion that we've got a second law of thermodynamics violation for a sky, it's a vacuum. But even if you don't shit-can it because it's not provable that you've got a second law of thermodynamics violation and you work in the paradigm, you don't know what you don't know between you and the sun.
No, but if you admit that part of the spectrum you're going to present as your full picture, you can't see because ozone does this, and part of it you can't see because of this, and therefore the only way you can get the full picture is to go into this second law violation. That, to me, is an admission. It's an honest admission, but it's there categorically stated. This full picture is to go to a place that doesn't exist, because actually we admit you can't get this bit of the spectrum terrestrially.
Right. They admit it, but they don't highlight it. They just go right past it. If you wasn't paying attention, let me show you something. Let me show you something. All right. So after they said that, is this in space? The McMath Pierce Solar Telescope at Kitt Peak, is this in outer space?
No.
Right?
No, not.
Nope, definitely not. So there's going to be some problems, aren't there? And we're going to get into those problems. Let's do it. So number 3, belly laughing train wreck. This is from nasa.gov. Listen up. The spectrum of the sun appears as a continuous spectrum. That's interesting. and is frequently represented as shown below. Continuous spectrum. This type of spectrum is called an emission spectrum, not an emission line spectrum because it has no lines, but an emission spectrum because what you are seeing is the direct radiation emitted by the source. In the case of the sun, light is emitted at almost all energies in the visible spectrum, which is why you see all the colors in the sun spectrum. That's very interesting. So a continuous spectrum, right? Everyone's got that? And there it is. There is the how would you want to say, the production from the McMath Pierce Solar Telescope at Kitt Peak. That's where they got it from. This is from NASA.gov right here. Okay. Question: how in the flying Fukuyama can the sun give both continuous spectra and emission line spectra, por favor? Does the sun have its own no atmo day too? Remember what I said up above. See, the spectrum of the sun appears as a continuous spectrum from NASA. From NASA again, .gov. When the light leaves the surface of the sun, it is very nearly a continuous spectrum. Well, okay, which one is it? Is it very nearly a continuous spectrum, or is it a continuous spectrum? They're double speaking. It sounds pedantic, but it's not. They lack precision and accuracy, I think, for a reason. We'll get to those. However, as it passes through the sun's atmosphere, gases present in that atmosphere absorb specific wavelengths of light. Remember, gases only emit and absorb in bands, leaving the pattern seen in the spectrum above. This pattern, the absorption line spectrum, right? By studying those lines and matching them to known lines from the elements, that's what Nathan was talking about. Because now they're referring back to actual atomic emission and atomic absorption spectroscopy that I showed in the machines above. That's what Nathan was highlighting. Astronomers are able to determine what gases are present in the sun's atmosphere. Really? NASA, make up your mind. Here they are. The spectrum of the sun appears as a continuous spectrum, or when the light leaves the surface of the sun, it is very nearly a continuous spectrum. All right, which one? We need you to be precise here. We need accuracy and precision in your language. So there's no, how would you want to say, linguistic gymnastics on the way down past this train wreck. Yeah, you're going to get it. Let's go to Hernshaw, the analysis of starlight at Cambridge, and Francis Jenkins and Harvey White, fundamentals of optics. Listen to this closely. Hot solid objects produce light with a continuous spectrum. Hot gases emit light at specific wavelengths. And hot solid objects surrounded by cooler gases show a near continuous spectrum with dark lines corresponding to the emission lines of the gases. By comparing the absorption lines of the sun with the emission spectra of known gases, the chemical composition of the stars can be determined. Is a ball of hydrogen gas, the sun in the second law of thermodynamics violation, a solid object? Do you see what they did? They just told you hot solid objects produce light with a continuous spectrum, specific wavelengths, and hot solid objects surrounded by colder gases, they're trying to denote the sun, right? Is the sun a solid? You wouldn't think so. See, this is what they get for lack of precision. Now, this sounds pedantic, but like I said, it's not. And you're going to see why it's not down below. Like I said here, is the ball of hydrogen gas a solid? Ladies and gentlemen of the jury, you're witnessing a convoluted gaggle screw of epic proportions. If it's not a solid, is it a gas? If so, then how in the flying Fukuyama are you getting a continuous black body spectrum from a ball of hydrogen gas? And you'd see the black body spectrum if my photo popped up that was good earlier before when I pulled up the presentation. Key learning objectives. Remember, gases only emit and absorb in bands. Number 2, how in the flying Fukuyama are you getting a ball of hydrogen gas and a 10 to the negative 17 torr vacuum without bludgeoning the second law of thermodynamics to a bloody lifeless pulp? That same goes for plasmas, by the way. If you thought all the above was a root and toot... Hey, hold up! Whose mic is open? Mic discipline, please. You're ruining my mojo. If you thought all the above was a rootin' tootin' cluster gaggle of double speak horse puckery, then somebody hold all these Baltards beers. Get ready, because this is the rub, folks. From lumenlearning.com astronomy. The dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun, absorbing those wavelengths of sunlight. Because the space between us and the sun is pretty empty, astronomers realize that the atoms doing the absorbing must be in a thin atmosphere of cooler gases around the sun. If your mouth just didn't drop right now, if you're not getting it, let me say this one more time. The dark lines in the solar spectrum thus give evidence, they're giving evidence of certain chemical elements. Where? Between us and the sun. Give evidence of what again? Well, certain chemical elements between us and the sun. Aren't we attempting to find out what the sun is made of? Not the stuff between us and the sun? Por favor? You see it, folks?
What?
Do you see it? Can somebody please chat what in the flying Fukuyama is going on here, folks? I'm going to stop right there because I think a lot of people have some things to say.
They're admitting to it. They were saying, here's what we're deciding we're going to measure. We're going to measure this, not knowing what's between us and it. And because we're measuring it, we can make these assumptions based on its emission lines. But it's almost continuous. I tried to interrupt you there, but you didn't let me. And the reason was because it's a great statement, isn't it? Almost continuous. Okay. No. You're either a digital clock, and it says number 1, and then it says number 2, and then it says number 3, and then it says number 4, or you're an analog clock. And there's always an in-between, between number 1 and number 2. You can't be almost continuous. It's just it's a contradiction in terms.
This is where the fairy tale dies. You see it right here, folks? I hope everyone's seeing this. I'm going to come back to it, but this is really the rub of the presentation. Once you see that, I could just put this up and stop. Couldn't I?
If it was put in an equivalent with terrestrial, you'd have certain equivalents, but in controlled circumstances, right? But it would be a solid that's not a solid, it's actually a gas. And then there's a layer of gas around that gas that you're having to look through, look at the thing that you say you're studying. It's got the characteristics of solids, gases, surrounded with an atmosphere of gases between you and it. How the hell are you going to actually figure out what the hell it is if you're disclaiming that you're looking through other stuff to figure out what it is?
Yep. Yes, sir.
The answer is you can't. It's a complete nonsense.
What galls me really is that that's it's not admitted, but that's obvious. But what they then go on to do, just to hide that obviousness, is to actually confidently place and explain why and where this this absorption is occurring, and then convolute it with even more contradictory bullshit by calling it a cooler band of gas around the thermonuclear hotballer gas. That's that double speak again. Get the bad bit out of the way, then give a just so story. So you just move on and then argue about the plausibility of it being a cooler air, a band of hot gas around the sun, as opposed to realizing what you just detailed. It's very clever.
Clever.
Just
Does it also need to? Is this the reason why they've got the sun not only being a gas in a vacuum in violation of natural law, but also violating the second law of thermodynamics by increasing its energy output as you get further away from it? Is that where they've got this from? Is that conclusion been drawn from stellar spectroscopy? I don't know, that's fine.
It goes, I want to add one more line. All of that hides the fundamental fact that John points at the beginning, that gases don't emit full spectra. No, they don't do it. Yeah, they emit in bands. That's the point of our understanding of terrestrial spectroscopy. Yet we're now told that it's emitting a full spectra. Yeah. Now, there's the bit of common, the bit of story, new add to the story now, where it's plasma, and John again highlighted at the beginning, they do use plasma in these things, but again, the plasma has to be contained. Now, according to their story, it's in the vacuum of space. There's no containment. But all of their plausibilities fall apart still. But to me, the fundamental one is that you only have to go back to that. Gases don't emit full spectra.
Yes, sir. That's why I keep on hammering on the key learning objective. Yeah,
it's almost continuous. You've got the band popping through the continuous spectrum, Adam. So it's almost continuous. The bits that aren't continuous through the continuous, I'll give you the emission spectrum. That's where you get it from, through the continuous spectrum that you shouldn't be getting from gases. But I actually missed what you just highlighted in the first part of what you just said, Adam, which was another second law of thermodynamics violation in terms of when they're describing it with terrestrial spectroscopy, they need plasma to be in a contained scenario to study it. Yeah, when it's in space, it's not a problem. We'll just decide that's what's happening. Why? Well, because we've just decided.
Too funny. Yeah, this is a joke, man. That's it. It's it. It's belly laugher. Let's continue with the belly laugher. We got another begging the question fallacy here. I like this slide because it gives people a visual on what they're trying to portray here. Right? So, this gives the three types of spectra. You got continuous on the left, you have absorption in the center, and emission line spectra on the right. Okay? We'll deal with the outers here quickly and then dispatch them and go with the principle because I want to focus here. So, like I was saying before, continuous spectra, and like they said, a continuous spectra you receive from heated solids. So, this is pretty funny. What's this light bulb with a solid inside, probably tungsten, doing out here in space? Are they trying to portray that this is like a sun? Right? Well, what they're doing is they're saying it's a solid. Or it's a false equivalence fallacy, right? I digress. So that's what happens. If you have nothing in betwixt you and the solid source of white light, you're going to get a continuous spectrum. Right? If we go over to the right-hand side over here, this is an emission spectrum. It's an emission line spectra, right? There's no light behind it. That's why they put it over here, right? This gets excited in a second law thermodynamics violation. Folks, there is no gases out here in the second law violation, okay? However, in principle, let's say we're in a closed system, you have gases. Once they're heated up, and the principle is correct. Okay, they're just not out here in fairy tale space. You're going to get emission line spectra. Why? Because gases only emit and absorb in bands. Key learning objective. Okay, so we could dispatch these guys over here. I wanted to focus here because this is what we're exactly talking about. So what they're getting here is an absorption line spectra. You have the fairy tale sun. A fairy tale solid sun because they're trying to portray it with a solid. here, which it's not, and you have a cloud of gas in a second law of thermodynamics violating fairy tale. So what they get is an absorption line spectra right here. So you see how close this one is to the light bulb sun? Let me ask you a question. Let's say you're 80 million, this fairy tale second law of thermodynamics gas cloud is 80 million miles away from you and 10 million miles away from the fairy tale light bulb sun. Are you going to get the same spectrum, absorption line spectra? That's rhetorical. The answer is yes. Scenario 2. Let's say this second law of thermodynamics fairy tale gas cloud is 50 million miles away from you and 40 million miles away from the light bulb sun. Are you going to get the same exact absorption line spectra? Rhetorically? Yes. Third scenario. Let's say this second law of thermodynamics fairy tale gas cloud is 20 million miles away from you and 70 million miles away from the fairy tale light bulb sun. Are you going to get the exact same spectra as you got with the other scenarios before? Yep. Let's say this second law of thermodynamics fairy tale gas cloud is 3,000 miles away from you and 92.7 miles away from the fairy tale light bulb sun. Are you going to get the exact same absorption spectra as you see here? Answer, yep. Does everyone understand now? Hopefully you got it. I love this slide. You want me to stop?
Actually.
Yeah, please, John. That was a point I think I made there with regards to it, and I think you make it with regards to where it is at the distance. As I said, they've already made a bold claim about it, produced mathematics with regards to it to balance the sun and the sun's energies. They've placed this cloud, even though it's in denial, around the sun to create those missing chunks. They've already defined in their paradigm, in their model, where it is, even though its behavior is strange if you put it at that place, because they have to call it a cool cloud of gas, don't they?
Yeah, we're going to get to that here in a second to cross the I's and dot the T's.
Yeah. Point being, with your analogy, that they've already placed it in their model. Yet, actually, the data is not able to tell you where the interruption occurs, just that there is this absorption that's occurred within the continuous spectrum that we see the blocks missing. So they define it. That's my point. They've already made a claim on that, exactly where it is.
Armin's trying to get in, but I just want to clarify what Adam's just said. They made it up themselves.
I agree with that. Can I ask my question? It's specifically to Adam, because I trust that he has actually handled a spectroscopy machine, or seen it at least in person at some point, right?
In a lab, yeah, we did emission. Yeah.
Right. So I got a question.
Mine would, yeah.
Question. It's kind of like an engineering question. I wonder if you've thought about it. But in spectroscopy, right, when it's actually established, okay, we're going to detect what this material is by putting it in the machine, right? So what's actually the distance of the light? I assume it's light or electrons, right? What's the distance of
the
that?
distance really doesn't have...
In order to get it...
the distance really doesn't have anything to do with it. It's what's in between
it does. In this question, trust me.
I don't know. I would suggest that the size of the machine would probably give you an indication, certainly as to the range. It was never something I've considered, Owen, in terms of what's important is the isolation in the machines. Yeah, that what the machine does is ensure
it's going to be measured in centimeters, Arwin. It's going to be a very small amount.
Yeah.
It's inside
right.
that machine.
That was actually what I was hoping for to hear.
In centimeters.
Right. So if and then like just cross-reference it. Okay, have they ever tested this? How accurate it is over distance? Like how long a machine can give an accurate reading, right? And then from that point on, move on to the heliocentric model and the assumptions of the distance of how far away the sun is.
I don't want to poo-poo you, but
Hold on.
distance is totally irrelevant. It's the distance is. You think it's kind of the point of contention with them is the non-isolation. They can have whatever distance you want if you can isolate that distance. Yeah. So that's not the contention. The contention is you go to all these great lengths with terrestrial to isolate it within. That's probably correct. A very small chamber to make sure the only thing you're analysing is the thing you want to detect and get an outcome from. Right? What we can't do when we're talking celestial is that whole box, that tube, that chamber is from here to the sun in this case, and therefore there is no isolation of the thing you're trying to analyse. It's subject to interference from everything.
Right. Well, that was actually my point. Is that okay? How much distance minimum do you require to get a stable reading? Well, I'm pretty sure that over too much distance, it's not going to read out. So how about that distance to that sun, right?
Let me just try once more. So in the machine in the lab, Arwin, got a lid on it, effectively. Let's say it's 3 inches between the sensor and whatever you're burning in the box and measuring the spectra that comes off it. Well, let's say you took the lid off and started measuring it from the ceiling a couple of meters away. Distance isn't going to be the problem. The problem is going to be that you've took the lid off.
Right, the gas in between.
Yeah, all the stuff in the lab, when I said, well, when they're measuring it in the box, they don't take into consideration the gas they're breathing when they're looking at the box or looking at the laptop screen, because the box is isolated. They don't need to concern themselves with what's outside the box that they're breathing because they're studying an isolated environment. Well, as soon as you take the lid off and put the sensor on the ceiling, suddenly you've got to worry about everything between you and the test. It's completely, it negates every single aspect of the test. No, I've used the wrong word. God, it's so well until that point. Until the study, it's not a test.
Right.
All right, we good?
Yes, I think so.
Let's dot the I's and cross the T's because it's dead already. I just like to be thorough. So, and like Adam said, cool, thin gases. We're going to deal with the cool, thin part right now. Right? And just take the whole thing and just beat it over the head with just a flurry of blows. So, letter C, cool, thin gases around the sun. Friggin' where? The photosphere, or what they call the surface, and by the way, gases don't have surfaces, is said to be 5,700 degrees Kelvin. The sun's atmospheric layers then go to the chromosphere. It's said to reach 500,000 Kelvin and is 10,000 kilometers thick. The corona is upwards of 10 million Kelvin and 5 million kilometers thick. Where's the cool, thin gases at that they're talking about? I guess it's all relative then, huh? Friggin' bozos. From Rochester Institute of Technology, thin gases emit light of only a few wavelengths. We call this an emission or bright line spectrum. If there is a source of light behind it, a thin gas will absorb light of the same wavelengths it emits. We call this an absorption or dark line spectrum. Again, the sun's atmospheric layers. The chromosphere is said to reach 500,000 Kelvin and is 10,000 kilometers thick. The corona is upwards of 10 million Kelvin and 5 million kilometers thick. Are the atmospheric layers of the sun cool or cold? How about then? You wouldn't think so, would you? So, now, if you think I'm telling tales out of school, I'm going to go ahead and allow Professor Vaught from New Mexico State University to speak to all those points and hammer them all the way home. How you like me now? So, I will wait a couple seconds after I play this, just to everyone to catch up in Discord. Please go on mute. Mic discipline, please. which we don't have right now. So we're getting ready to go. And the diagram is up for you guys. She's using this diagram. I nicked the diagram off her, and she's going to explain what's going on here. So I'll just let her deal the death blows. Hey, here we go.
So now that we have the idea of colors going through the spectrum, and of a larger spectrum that contains colors of shorter wavelength or of longer wavelength than the human eye can see, we're going to take those ideas and apply them to spectra, figures or plots showing the dispersed light spread out as a function of wavelength, and we're going to consider the astronomical applications of spectra. So we begin by building on the atomic theory that we developed last week. We know that a given atom of some species will absorb and emit energy at the same frequencies. So if it absorbs a photon at a particular frequency and has an electron jump up one or several energy levels, inevitably it will emit the same amount of radiation when that electron decays down towards the lower or ground states within the atom. A cool gas of hydrogen atoms, for example, will produce an absorption line spectrum if it lies between you and your telescope and a continuum light source. So let's think about this and develop this picture a little bit. In our first diagram, on the left we have a white light source, something that emits smooth continuum radiation at all frequencies, and then we have a gas cloud, which is much cooler than the star and is filled with atoms, represented as small circles within the cloud. Our white light source, if observed directly, would produce continuum radiation at all frequencies. But what happens if we look at the star through the cold gas cloud? We know that the cloud is full of atoms. When we say that it's cold, we mean that the atoms contain electrons that are in low energy states, which would just love to jump up to higher energy states. So we see colored beams of radiation coming from the star in all colors, meaning that it's emitting light at all wavelengths or all frequencies. Those photons, which contain exactly the right amount of energy to enable electrons in the gas cloud to move from energy level to energy level, are the ones which are absorbed by the gas cloud atoms. So when we look at the star through the gas cloud, we see a continuum radiation source with light preferentially removed or absorbed at those key frequencies. So this is like a fingerprint. Once you match up the wavelengths that are missing from the continuum spectrum, you know exactly what elements were present within the cloud. Now you may wonder why the radiation is missing from the beam of light emitted from the star when you know that the atoms in the gas cloud will be excited and then de-excited. Let's think this through carefully. The electrons are elevated to a higher state within the atom, and then, given a little bit of time, they decay back down to the lower energy states. So in essence, all of the atoms in the cloud are absorbing and then re-emitting the energy which they take from the star. If that's the case, why doesn't that energy just fill in back the holes in the continuum spectrum, causing us to see a perfect continuum spectrum in our telescope on the right? The answer is very simple. Once an atom absorbs a photon, it loses all of the information about the direction in which that photon was traveling. The electron absorbs the photon, takes that energy to climb up to a higher energy state, and then when it falls back downwards, that photon is re-emitted in a random direction. This is the key point. And the result of this is that the gas cloud emits that radiation isotropically, meaning in all directions. It doesn't send all of the photons back along the beam of the star in the direction in which they were traveling before they were absorbed. Instead, they get scattered in all four directions to the winds. We can see this by placing another telescope, one that only looks through the gas cloud but that does not see the star. Imagine that the star and the gas cloud are separated by quite a great distance, as are the telescopes, so that we only see very narrow beams. Much as when you look up at the sky, one individual star only covers a very small angular distance on the sky. Now with our second telescope, when we look straight through the gas cloud, what do we see? Well, if there's no strong source of radiation present, if there's no star, we don't see anything. The cloud is cold, remember, and what that means is that it's not emitting energy on its own. The situation gets more interesting when we add back in the source of continuum radiation on the left. Once we do that, Our gas cloud has a ready source of energy. It starts to absorb photons and re-emit them. And because it's re-emitting them in all directions, some of them are going to fall into a line that points to our second telescope. We don't see the continuum radiation from the star that passes through the gas cloud. What we see is only the radiation re-emitted by the cloud. So what we see now is an emission spectrum. At most wavelength, there's no energy whatsoever. But at a few key wavelengths, those that correspond to the energy levels of the atom within the gas cloud, we have extra light. If you combine this emission spectrum with the absorption spectrum that we get by looking at the star through the cloud, the combination, in effect filling in the holes in the absorption spectrum with the emission spectrum, leads us to the original continuum spectrum. Light may be divided into two paths, but it's neither created nor destroyed in this process. A very elegant process.
Turn out the lights. Party's over. You're done. Baltards. Your fairy tale spectroscopy. It's over. It's through. You're finished. You go parroting this nonsense around me, I'm going to drag you around by your short hairs, then eviscerate you and allow my wolf pups to feast. Because I'm going to catch you. Just waiting for everyone in Discord to catch up.
That was fascinating.
Well, I was going to ask a question. Is the premise of her description based on the idea that the star is a solid?
I would say, yeah, she said continuous spectrum. It's either a solid or plasma in a container.
But yeah, no, I didn't. It's not plasma in a container because it's not plasma in a container. Where's a container in a diagram? That's clearly obvious just by a depiction. Therefore, you're left with only one option, which is that she's depicting it as a solid.
Yep. You guys want to allow me to conclude and then you can go at it?
Yes, please.
Yeah, go on, because I've got a point.
Yeah, I'm going to conclude real quick here, and then you could just go right at it. Remember, key learning objectives. Gases only emit and absorb in bands. You see it now? Hopefully everyone sees this now. I give this presentation twice this time. Hopefully everyone, it's kind of getting through to everyone. Let's go in and conclude. Number 1, belly laughing bait and switch equivocation fallacy. That's terrestrial versus celestial spectroscopy. Number 2, NASA is unsure whether they're getting a continuous or absorption line spectrum from the sun. These bozos right here from Cambridge and Jenkins and Harvey think the sun is a solid. And number 4, this is the kicker right here, man. This is what I live for. I pine to read this. This is what the whole presentation is about. Again, Lumen learning. The dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun. If you don't understand anything with this presentation, if you get this, then it's curtains for the ballers. Curtains. Absorbing those wavelengths of sunlight. Because the space between us and the sun is pretty empty, astronomers realize that the atoms doing the absorbing must be in a thin atmosphere of cooler gases around the sun. And Professor Vaught just explained to you the whole process. Just like I did. It's the same thing. No tricksies. Letter A, give evidence of what again? Well, certain chemical elements between us and the sun. Aren't we attempting to find out what the sun is made of? Por favor. Not the sun, not the stuff between us and the sun. Right? Isn't that the whole point? I'm just spitballing. My God. Can somebody please tell me what the flying Fukuyama is going on here? Thanks for your ear. Have a nice day.
Whistling past the graveyard. We're not studying it, but what we do know is between us and what we already have decided what it is, must indicate that the things between us and the thing we don't know anything about and can't study because the stuff between us and it is as follows. Pay close attention to the stuff that I'm going to tell you about what's between us and it, and I'll whistle past the fact that that means I'm not actually studying it anymore.
That's Nathan, what's the housekeeping question with regards to astronomy? Just the any viable hypothesis, yeah. It's almost a level of supporting emission spectra that you could use in that diagram the professor sets up. The only issue is that it wouldn't appear to have ever been validated what she talks as if it's reality about how we can understand what these nebula emit, etc., and why they're emitting it. Because to do so would require them to admit parallax. Yeah, for us to have got in a different position to confirm from the different angle that the absorption spectrum and the emission spectrum match up when you take them from the different angles. Yeah, but we've never ever done that because A, in reality, the things rotate a step above our heads altogether. There is none of that. But B, in their model, they stick it so far away that you could never ever have parallax. So even in their own model, they couldn't validate. What they're telling us here is why they draw conclusions from the emission spectra they get.
I agree. I agree, but by the same token, you're right, and that is a problem because where they're going to get this third position to look at it from 90 degrees to get the bars rather than the lack of bars through a continuous spectrum. Well, how are they going to get that third position? Well, if you start arguing along those lines, they'll just start telling you about how they've achieved that position in space, and they'll take it to a second law of thermodynamics violation. You're whistling past the overall problem, which is that this description is of them basically disclaiming that they can't see the thing they're studying, and they're having to study something between it and the thing they're studying. So they detail that and get you to, as you've done, I'm not knocking you, Adam, but you start arguing, well, how do you get 90 degrees to the cloud and the cool gases to see you've got the same radiated patterns in all directions that were part of the missing bands? How do you get to that position? Because then they'll tell you. It's like, no, don't whistle past the fact that, so we've got something between us and it then. You know what I mean?
Yeah. It's a joke. These are these jokes? See, it's just surface. Once you start to dig right beneath the surface, that Formica deep surface, the whole house of cards collapses. Because all their contingent necessary facts are not holding. There's nothing there. The Emperor, he's not even, it's not that he's not there. Even there, or doesn't have any clothes, he's not there. There's nothing there.
Yeah, to link it back to Arwen's point, when you take the lid off the box in the actual controlled spectroscopy scenario, got terrestrial spectroscopy studying stuff in controlled situations in an isolated chamber. Well, when you then disclaim that you've got the lid off the box, the camera on the roof, the detector on the roof, and you're looking at the reactions that are happening with stuff between you and it, back to the you don't know what you don't know. Well, yeah, you might be able to come up with a reasonable cogent explanation in a second law of thermodynamics violation how you get 90 degrees to the clouds are cold, and therefore you've got the re-emitted energy as it drops down, it drops through the shells. But when you describe that, you're still not addressing the fact that you're not achieving what you're setting out to do, because what about the other things that you haven't yet detailed? Okay, yeah, you might be able to say that in your totally uncontrolled scenario when you claim you've taken these 90-degree pictures in a second law of thermodynamics violation. But you're still not getting to the point where you've isolated what the sun is. You're still not studying the sun. It's all sorts of things you haven't accounted for, and you don't know what you don't know, even if we beg the question of a sky vacuum.
And coming back to Arwen's point, in terms of proximity, they boast that they use to analyze these things. Even them are 92.998 million miles away from their source, with all of the possible contamination that creates. So there is no validity. I remember John Dee saying it, he just laughed when he said, well, what would you do if you took the side off the machine and that? Well, I'd laugh, any results I get are no longer valid. It's pointless doing this.
Well, in order to achieve an actual sort of halfway reasonable reading, it would have to do it from within space.
You can't. You're missing the point, I think, Arwin.
I know.
It's not isolated. What they're studying is not isolated. But therefore, there's other factors that you have to start detailing. And the description we heard from, I've forgotten her name, but her description summarized how you're having to factor in and study the things between you and the thing you're studying. That's the problem. That's the main problem here.
Yes, sir.
If there's no parallax and all you've got is this emission spectra to look at and no alternative angle to look at it, how do you know that there is something between you or not? All you can do is presuppose what it is and where it is, with no validity, just something that fits your just so story.
She did actually say she'd done this, though, did she? She said this is how you would do it. She's giving you a story about how it would be.
Exactly. This is how you would do it. If you could go into space, this is how we would validate the diatribe I'm about to give you. But we haven't, because we can't. But if we did, what I'm about to show you, all of it is based on terrestrial controlled spectroscopy, yeah? And this is how we would validate it based on what we know, what we've learned on the Earth in these controlled environments. This is how we'd set it up. This is how we would set it up.
And now
Not
let's
how we
focus on the
confirm
stuff
it.
that invalidates the whole process, because it's actually between us and the thing we're studying. So let's now focus on how we achieve a reasonable explanation for these missing bars in a full spectrum that should be coming from a solid when we study the thing between us and it, basically detailing how we can't do the thing we're supposed to be doing.
Back to yes, minister, isn't it, Nathan? And don't ignore the fact that the thing wouldn't work even if we could do what we're about to propose. Yeah?
What are you
Because
talking
we've
about?
still not contained it, have we?
What are you talking about? All you need to do is send out a satellite up into very high orbit outside of the reach of the gases of Earth, and then spectroscopy measure it through the vacuum of space.
And you've confirmed that those other 92 point whatever million miles are vacuum with nothing in it that would affect that spectrum, yeah?
Negligible.
Have you swept your
know what you
chamber?
don't know.
No.
It's not negligible. You don't know what you don't know at this point. Even if we beg the question of space, which we're now doing, and saying if we were to go out in space, well, it's a vacuum, we can safely assume that... Well, no. If we beg the question that the sky was a vacuum and we go out and we achieve a parallax position so we can see the emitted... The description she's just given, I'm not going to go through again for a third time. If we achieve that, it just invalidates the whole process that you're trying to achieve in the first instance, which is measuring the sun. So we're into describing the clouds between us and the sun. All right, not the study of the sun directly then. That's the problem. So we're now into, you, me, Arwin, we're all into arguing about how it would be achieved to study the thing that invalidates it then, the cloud between us and it. So that's not whisk past the graveyard.
Well, hold on. There is another possibility. I don't see it personally as very fruitful, to attempt to figure out how light responds through air, right? And then you could, it's kind of like, what do you got, P waves and S waves? It's probably not going to yield a lot of success, but it could be attempted so that you could still keep measuring it at ground level.
I agree, Arwin. And spectroscopy itself is fascinating. You know, have an extended conversation with Dr. John Dee about spectroscopy. It's a fascinating study. Really, really is. And, you know, there are certain questions that I've been biting my tongue on during this whole show, because there are questions about why. Yeah, why does it absorb when there's a light behind it? Can you give me an example of that in our reality, that I can quantify that in a way that makes me understand the way of our experience of the world? In other words, there's lots of questions that might follow on from spectroscopy that all hinge around why does that happen. And John already disclaimed it. Good job he did, because I'd have been interrupting non-stop. Well, why does that happen? Well, why does that happen? Why does that happen? Well, the answer is we don't know why it happens. This is just what's happening, right? And it is fascinating, and I'd love to know why. You don't. That's why I had to correct myself when I'm like, it's a test. No, damn, it's not a test. It's a study.
We can attempt to figure it out and then test what our models, and then see if it's correct in some way. If there's
What?
some way to figure it out.
What?
No.
You need to start snorting those beers.
Yeah, well, don't poo-poo him too much. If you wanted to figure out the cause of the absorption, right? You could call a natural phenomena, and yes, you could try and put it through the method. Nothing wrong with suggesting that, Arwin. I know you've been poo-pooed. The exasperated tone from QE is because this is another one of those things like the second law itself. I don't think we're ever going to find out why. Correct me if I'm wrong, QE.
No, it's forever illusory. It's the acme of foolishness.
Do you think it is foolishness? I hate that.
Look. It could be foolish, but it depends on our understanding of light, which is being used in the first place, right? So if we understand further the nature of light, then we might yield more understanding even of how spectroscopy works, even through other materials. Who knows, right?
Say it 3 times fast.
Spectroscopy.
Because you called it, every time I say the word, I'm nervous. I'd sooner say spectrochocoloscopy than the real word. I'm more, I'm too scared of getting it wrong.
Establishment of the cause, just to address Arwin's point, because it's been belittled and I don't like it. Asking that question is the driving force in science. It's saying, well, it will be forever illusory. I say that sort of thing with a wry smile because I think, no, somewhere out there, somebody's saying, what causes that? And they may set about a journey on figuring it out. Might actually result in them figuring it out.
No way.
Yeah, in cheek. I don't think so.
You're asking the wrong question.
What's impossible? I'm lost. Just clarify what's impossible, or what are we suggesting?
Why the light absorbs, for instance. When you've got a light behind it, why do you have an absorption spectrum? Why does the light stop emitting? Why does it start to absorb that spectrum? Well, that's a phenomenon. You could figure out the cause.
You've got no chance.
I don't think so either, but I think...
No. That's why does creation work? Don't ask that. That's just too much.
Oh no, but Nathan is onto something, because the technological implications could be that you could literally over a distance just detect the detailed spectrum of material or something.
No, John at the beginning.
It's a worthwhile exploration.
He's going to just reply.
Yeah.
Right. Number one, Adam, yes, you're right, and so is QE. And I actually agree with you. I think it will forever remain illusory. It's like asking why did we have the beginning of creation? What's the cause of entry? I think it's along those same lines. I agree. What I'm trying to get across is when Arwin asks those sorts of questions, which is very Arwin, the world needs Arwins asking those questions, not me, you, and QE saying it's going to be forever illusory. As much as I agree, we need that
Adam,
sort of question.
1 second, Nathan. 1 second, Nathan. I don't want... Adam, your mic's feeding back, man. It's audio chaos.
Oh, sorry, dude.
Yeah, go ahead, Nathan. Sorry to interrupt.
Up with Discord, because when it says I'm off mute, I'm on mute and various things, so it's just screw Discord today, I think. Anyway, yeah, I agree with Adam. I agree with QE. It potentially, I think I agree, is forever illusory. And we're not going to get the answers to what causes this stuff from spectroscopy. By the same token, it needs people like Arwin out there actually asking what causes these phenomena for them to ever be considered studying. Now, I applaud that, and that's the joy I get from Flat Earth, and I don't want it demeaned, as much as I actually agree with you saying, no, I think it will be forever illusory. I agree. And I agree with Adam when he's like, no, it's like asking what's the beginning of creation. Just don't want Arwin or anybody else to stop asking or attempting to find out why. Why not?
Right. To me, it seems just like a worthwhile attempt. Why not?
It's forever illusory. You silly.
Exactly.
The bit I was trying to talk to, QE at the beginning described the movements, the positions M1, M2, and downgrading and releasing energy in that relation to emission spectra. We've got all of that, right? And we know all of that, and it does that. But we don't, all of that extra detail we've learned over these past 50, 100 years, right? None of it's added to the why. It doesn't explain why it's moving from there to there, why it quantum leaps. If anything, the more you learn, the more confused. Things were simpler when you knew less. The more you know, the less you won't actually understand. Yeah, it would make sense if it emitted a smooth array as it transitioned from A to B. Yeah, that would make bloody sense in a physical world. Yeah, but it doesn't in quantum leaps, and that's why I said, "Oh boy," yeah, because that's the reality. That's why Sam says it. Oh boy, it just blows your mind. It just goes from there to there. There is no in between that moment.
Are we talking about Sam and his energy state jumping between shells, and this time he hopes
yeah,
that will be the voyage home?
Yeah. Now you have to let's slow down a little bit. It depends on the question that you're asking. I don't think people in the audience, we're making general statements. Now, it depends on the question that you're asking. Not all of this is outside the realms of finding out the cause. Certain parts in it, right? So if you'll be specific, Arwin or anyone else, if you be specific and put your question out, then we'll evaluate it, each on its own merits.
John, there's a cause that we get to the point that a certain energy state is released, and light is emitted, yeah, and that allows it to go back, as you described earlier, to a much more relaxed, its lowest energy state, its least excited state. It's happy to be there, it wants to go there. It can't get there till it's got enough to emit enough of a packet of energy to create a photon. Yeah, so we understand that, but that's fine. That's the mechanics of it. Why it does that, I ain't got a clue, because I learned why it did it years ago. I've added nothing further as to actually why. You understand? That's why I think there's a level that you can reach in your understanding, and that's when you get to the quantum, and you have to understand that whatever's happening isn't happening in the way we comprehend things. And that might be defeatist, but I don't see a way past it.
Also raises a new question. Precisely how happy are they when they reach that state?
I'm buzzing. It means it's a creator.
So have you guys come up with a question yet? Because I'm not just going to hand wave stuff, and I'm sure Adam isn't. If you guys got a question, remember, you got to phrase the question correctly. So what's the question?
Why do you get absorption?
Why do we get absorption line spectra through gases? Is that your question?
Yes.
I explained that at the beginning of the presentation, where those atoms, the cold, thin gases, are in low energy states. And if you have light passing through there that contains energy, the electrons in the gases with their shells, now it has to be the right amount of energy, right? It has to be perfect to kick those electrons up into their energy levels. Different gases, different elements, different atoms will have different energy levels, right? If it doesn't get that amount, then guess what? It's going to transmit right through. Ain't going to do anything, right?
So the cause of the energy then, so the cause of the jump between those different states, as you go up and a less relaxed state, as you go up in shells, I know you gave the disclaimer about orbits at the beginning, so I don't need to go through that.
Yeah. So
cause the amount of energy.
The cause of what?
Why it jumps up through those shells.
Why electrons jump up energy levels? Why? That's the question. You can't answer that. It just does. Just is.
That's the why question I'm asking. Why does it do that? Why does it jump between those states?
Because God said that's what it's going to do. Where else can you go? Am I understanding the question?
Yeah, it just that's the point I'm making, Nathan. We describe what it does, why light goes into an atom, does this, yeah, and then creates that effect, and then releases that effect, breathes out with the light, yeah, and why it does it, I have no idea. You know what I mean? The majesty of that and how that makes everything work is just beyond comprehension. I can only just about grasp in a mathematical way the behavior of that electron. And I certainly can't grasp it in a real physical way. That the descriptions we're given are analogous to the mathematical behavior. It's not what happens. Do you get me?
That's kind of where I was going to, Adam, actually, because I was wanting to expand on. I didn't want to phrase it initially as why doesn't it do something. But earlier, Adam was saying, why doesn't it go through the transitionals? And why isn't it analog? Why isn't it sweeping from one to the next? Why don't you see the smear? Why does it go? Why does it have the quantum leap? There you go.
That's what you right, exactly. Well, you can ask the Lord when you see him.
Because the model that we're using to describe it doesn't describe it. You understand?
We're asking the wrong question. We're not describing what it does correctly, so therefore we're having to ask a nonsensical question because of our crappy description.
The model that I understand that we all use with those electrons and those shells and those orbitals, right, isn't reality. It's the best comprehension we have from mathematics, from a probability distribution again, in terms of those placement, those things, that we can build a comprehension about roughly what's going off in a physical sense. This isn't necessarily a physical thing that's going off, is it? It's within the bowels of creation. It's how the basics work. It's how your PC works. You know what I mean? It's not your PC. It's what's going off inside the PC. Just because you can say there's a bit there, there's a bit there, there's a bit there, doesn't mean has any relation to what's going off inside the computer. Do you get me? Or a light comes on when I press that button. That's kind of where we're at.
I want to input something because it's all dependent, really. All these things, all the details, all the caps on the details, it's really dependent on the photosensitive material or electro-responsive material, right? So, yeah, maybe a solution could be found in artificial materials to somehow size the sensitivity even up, like to make the material that is going to be interacting, whatever it's going to be, to respond even quicker to light interaction or electric interaction and get an even more sensitive reading, right?
How do you see something in an optical sense that doesn't emit light? And that's what we're talking about, trying to visualize things by how we see the light they emit. Now you're talking about things that don't emit light. Well, how we don't comprehend them in that way. Do you go
well, maybe because if you deepen the sensitivity of the receiving material, the difference between light coming from celestials, including the sun, and actual material reflections just become more apparent, right? So the patterns crystallize clearer, the difference become more glaring, right? Who knows?
You're trying to.
I was talking about the electrons moving. That's what I meant there, Armin, in terms of you can't see something that isn't visible. It doesn't emit light. What's going off has no light to it other than that point, that quantum leap. That's the only point light's involved. But to actually see all the other stuff, there's no light there to see it. There's no light generator for you to see that mechanics. The only way you have a scanning electron microscope is to scan with electrons and see what pattern that they bounce. That's more detail, yeah, than we've had before, but it's still not seeing. That's a point of submission. I have to admit that you'll never see these things. As much as a chemist, you think, lovely. Yeah, but how can you?
Well, what is the most photosensitive material that exists, right? Is it similar
You're going to
to
go around in
in your
circles.
eyes, or is the plate even more sensitive, or so
Owen, please,
it all depends
please.
on the sensitivity.
Owen, you keep asking about getting more and more sensitive to see something you can't see, and we're just going to go on doing this forever. Can't if it's not emitting anything, you can't absorb anything. So it doesn't matter how sensitive it gets.
If you think of the atom, Owen, and as we imagine it, right, there's no light reflecting off of it, coming from it for you to actually see the atom. The only time light's involved is when it's emitted from the atom, as described in there during those things. But that is an emission of the photon, isn't it? But it's not a description of the thing it left behind. That makes sense?
Yes, it does. Right. Okay. So I understand the complication. Right. I kind of dwelled off just on this thing for the photosensitivity.
No, it's a good question. It's good that you're verbalizing your cognition as you go through it, because it gives us a chance to reiterate it. If you're thinking it, there's going to be someone in the audience processing it the same way, so it's good.
Right.
Hey, Nathan, you got the con, man. Give me 2 minutes.
Okay. Well,
Oh, you hate that. He could have just left and we'd have carried on.
Now, if I would have left, right, and someone, well, where's QE at? Well, I'll just solve that problem right now. Just 2 minutes, man. I'll be right back.
I got a good filler for you guys to ponder on, right? So I just discussed like potential photosensitivity material, but maybe even like how accurate is actually like the electron charge idea. Like how stable is all the material interactions according to the electron division model, right, of energies and all that?
That's where I would call a ball of Mong and go, how do you think computer works? Is what I'd say to that. I think it's pretty stable.
No, but I mean, yeah, not as like, it goes back and forth. It's rather that, is it all exactly in that division as chemistry makes it out to be, right? Exactly in that. Or is it just a really good estimation?
It's a very good estimation, I think, as the
right
list answer.
So it's not like absolutely perfectly exactly as is stable, right? Because that is what the math would suggest.
I think it's, as I just described, it's nothing as is via the model. Yeah? Now, the model is excellent in many ways, predicting reactions, electron positions, etc., etc. As I said, that's as best as you can understand it in the physical sense, physical being things made up of atoms. And yet we try to comprehend an atom as if it's made up of atoms. That, I think, is probably the misnomer where you've got to be honest. Is it?
Well, it's to make it a little bit more mathematically tangible, I think. That's really why they did it.
But if atoms were made up of smaller things like atoms, then it wouldn't be called atoms. The smaller things would be called atoms. And I know mathematics has tried to invent these things for things we measure. Reactions, results we get, but the smallest thing we've got, I think, that we can quantify with an electron microscope, we can see this single entity, and it behaves as described within the model. And we can create an image that looks like a sphere with it bouncing electrons off it. It's as good as we can see.
Well,
and that confirms the model. It doesn't destroy the model, but I think to pretend that means the model's true is well, egotistical and fundamentally ignorant.
Well, would you even call the electron microscope readout? Would you even call that actually seeing, or is it rather rendering based on the detection patterns?
It's not seeing. Seeing is what we have with our eyes. It's the effect of photons hitting things, isn't it? What sight is by only an electron microscope is pattern created by firing the electrons, seeing how they rebound. Yeah, so it's not seeing, is it?
Right.
But it's similar. The way I think of it is, get those like pin things where you can put your hand in it. It leaves the shape of your hand in all the pins. That's what I scan an electron microscope. I can see it's a hand still. Yeah, confirms my model's not incorrect. It doesn't add any real detail to my model. Kind of shows the position, what I assumed was there anyway. But it at least confirms and assumes the position, doesn't it?
It's a very effective and ingenious idea to come up with it. But I have reified in my mind that it's actually like a really zoomed in type of sight situation, and it's not. It's really a rendered model what you get to see. But the accuracy can be quite astounding, right? But it's a whole different type of process as the interaction with light. But yeah, because of the rendering, it's still very. You do kind of reify it almost in your mind. I did when I first saw those images. But then I started to detect, like, wow, I see like distinct patterns in this. There's a fractal nature to it, and that kind of revealed to me, like, okay, this is actually a rendering, representation, not actually like sight.
As John said at the beginning,
I'm back.
I don't think electrons are going round in an orbit. I don't think that's what they're doing, whizzing round. I don't think it's physical like we imagine. And just like their movement, one energy state to the other, it's quantum, just there. And when we try to measure them, that's when we locate them. Somebody help me. This is the uncertainty paradox, isn't it? You know, so it's in a complete. The quantum realm is part of creation to me. When we delve in it and we see sneak bits of it, we're able to get confused by what it shows you. That to me just reveals creation, that it's within something that sits out of that physical rules that we obey. And double slit demonstrates that none of this sits within the physical realms, that even when we try to describe an atom, we try to apply those physical rules to it. And I don't think they apply if you want to do the truth of what's going off in an atom. I think it's part of creation. It's part of what was decided to be the function in this experience for us. And their tiny minuteness, I think, is part of the initial genius. How that works leads to how everything else works. Yeah, but how that works is so fundamental. But how it does, I ain't got a clue. And I don't think we ever will, because I think it's key to creation.
Seeing it do it, having the ability with things like electron microscopes, at least give you a sense of what's going on. I can't remember how you phrased it a second ago, but it brought a big smile to my face when you're like, it gives you the opportunity to become more confused. You're like, you get to look at it and go, wow. But that's about it, right? You're not going to figure out the cause of why you're seeing those occurrences, or you're going to figure out why it does it in that way. So what you're left with, oh, I feel ignorant. What the problem comes when people do try and describe them with, in some ways, sort of causal attributes ascribed through their models, normally through reified models. It's got to be said that there's a lot to be meaned about doing that. While you chalk them up, Adam, you're like, yeah, useful. You're saying it in a way that gives the disclaimer that you are aware of the danger of them, right? You are acutely aware of that, and that is where the problem comes in. Because it is arrogance, right? We want to be able to describe these things, and they are beyond comprehension. They're trying to figure out the cause of existence of our reality is what we're asking, and it's too steep an order to fulfill. But we still want to. So arrogant people attempt to do, and they reify models in order to do it. And the people who do it end up with egg on their face, and that's where we're at now. That's why we end up with these sorts of presentations on how spectroscopy will evolve from a study that's interesting, that does give you answers about how stuff behaves, to trying to expand that out at a macroscopic level and explain things that are so beyond the scope of your... I don't want to demean spectroscopy in this, when I say it this way, but this crude study, and it is crude. Again, I'm not knocking who study spectroscopy either, but by comparison to the kind of questions that it brings up, and Adam says, well, it leaves you feeling silly, or whatever, I can't remember your terminology. But yeah, exactly, it's a crude study, just opening the gateway to much bigger questions that you're more likely than not, leave a little bit of wiggle room in there, going to find answers to.
Ego, I think you related to, or arrogance in terms of understanding, because I can mix two things together and know what I'll get at the outcome. That's predictive, it's knowledge, and we've built a model around that. And I say it works. Doesn't mean I know why it works. Yeah, I've got predictions in terms of why electrons move, and those are predictable. But why the electrons move? Why all of these things were set up like that? I have no idea. It's a bit like knowing if I put a chip here, a chip there, a chip there, but I have no idea how the chip's built. It's just a little black box. That's what we've got, little black boxes doing things that we think we understand. But what that little black box really is, we don't. And that's the concern, that you have that knowledge. And I'd say I had that knowledge and that arrogance, Nath. Yeah. And then when you explore more and more, that's when arrogance is eaten away. As you bother to ask those questions, you take the arrogance away from yourself, don't you? Because you're honest with yourself and look at them things and say, yeah, I don't know anything. And actually, the more I look at, the more I learn, the more I understand, actually, I'm never going to understand what I thought I understood. The majesty of it is too great. And that's the reality, the majesty of what's going off. Too great. All I can see is basic mechanics.
I don't know if you were there, but we had this debate a couple of days ago. Paul trying to describe how start off with a reasonable, what you think is knowledge of things like this. If you take sort of an atheist worldview, you're at the peak of excellence, right? You're the most advanced thing in your known existence. Right? In other words, the way that you're positioned is that you're at the top of the tree. You should know this stuff, right? You can figure it out. You're as smart as it gets. Like, yeah, but that's when you put yourself at the top of that tree. However, you then come to things that you think you've got a reasonable understanding, and I described it on the debate as having two circles. One circle is known, understood knowledge, and it's a big pile of rocks. And then in the other pile, you've got stuff that's actually been studied that you don't know. It's just left you with actually, I didn't know about that. You start turning over some of these rocks and looking at them and studying them. And one by one, you put them all in the pile that's I actually don't know. At the end of the process, you go, well, do I feel smarter or dumber for doing this? I realise now that I know far less than I thought I did. So is that I'm much smarter now? Because when I position that to Paul, it's like, no, but you've gone through the process, so you must be smarter because you now know that you don't know that.
You're not smarter, you're more knowledgeable, aren't you? You have the knowledge that the knowledge you had previously that you held in esteem is actually not as worthy as you thought it was.
Or to paraphrase that, I know that I don't really know that now, so I'm really smart.
Yeah, that's the reality, isn't it? Unfortunately, but that is an increase in knowledge.
Oh, it's a decrease. No matter which way you dice it.
That's an increase.
No, it isn't. It's a decrease.
It depends, doesn't it? Whether you're talking about space. I'm talking about chemistry. I think from an honest point of view, if you get to that understanding, it might help you develop, because what it stops you doing is sitting in a paradigm. If I was to sit in that paradigm where I thought little E's with a negative sign raised to them, flying around a little cluster of P's and N's, yeah, and I stayed in that paradigm because it worked, that would inhibit me. So knowing that that is false, extra knowledge that what I did know is false, leads you to further knowledge, because it tells you to step outside of your tried and trusted method, because it's not a full explanation. And that's kind of where I see chemistry.
Yeah,
Did I get out of that?
There's obviously exceptions. You know, if you go through the scientific method in terms of knowing why light diffracts, you know, acquiring knowledge of the witch path, acquiring any experimental validity does expand your knowledge. But there's so limited. It's so limited, right? How much do we actually have that's scientifically valid?
I'm trying to apply it to space. Like, whereas actually, you're correct. If I think about NASA and all the stuff there that you thought you knew, and then and actually all of that's gone, and you are now left with nothing, absolutely nothing, other than lights in the sky. I suppose it's horses for courses, isn't it? I suppose you apply it.
Yeah, indeed. A lot of my description in that regard is going to be in terms of what's been applied 99% of the time and called science, that you've sorted your way through your education thinking you know stuff, and then you find out that you don't, and you feel less smart for it because you've relinquished some of that. That doesn't necessarily tally, as I just said, when you go through something that's got empiricism attached to it. Find something else.
Yeah, and that's probably why I'm defending it, Nath, isn't it? Because and that's the difference. I'm not defending, let's say, the P's, the N's, the E's, and the lights. I am defending the empirical side of stuff, the things that if you do A, X, and Y, you get Z. Yeah, those things. And that's what I'm saying. When you get to that fuller knowledge and you realise the model you're given isn't reality, that's when there's a chance of further learning outside of it for me, not sitting in that paradigm. And what we started this on is thinking you know everything. You can extrapolate that, you know, to the universe and the likes. So
appreciation of how the models work, how they can be usefully applied, will leave you in a better position overall, which you could easily argue as knowledge. When you and I were discussing the guy, the politician, the English politician, name eludes me.
Rees-Mogg.
That's what's written all.
Jacob.
Mogg, right?
Rees-Mogg, yeah, Jacob Rees-Mogg. Yeah.
It was written all over his face, and he was saying, "Well, all the world's a stage, and out there's an even bigger one," right? In those words, he communicated to me that he probably does understand this stuff. Probably understands these models. Yeah? To be able to rattle that off in the smug way that he did. Yeah? Now, does that make him more or less knowledgeable in this context? Well, more, because he's able to deal with somebody who's not got that knowledge that it's not knowledge in that respect. So it's advantageous, and therefore, yeah, I can see why you'd fight it, and still back my point, which is to say that as you look through stuff that you thought you know about space, you realise you know less and less about the world you thought you lived in, and therefore you've got less knowledge. But by the same token, it doesn't mean that you're just going to, you know, this journey's for nothing and you're going to end up a dribbling zombie at the end not knowing anything. No, that's not what I'm saying.
No. You get to space, it impacts a lot of other stuff.
Sorry, Adam, go ahead.
Oh, no, you go. Double speak that was, weren't it? So I will go. I say when you get to space, it's worse because it unpacks so much other stuff. But this is the important. There's still the science, the empirical, tested, repeatable stuff that we have. We use to validate it. And some of that chemistry of that, even though I don't know what an atom looks like. You get me? So is we have empiricism, and that's why philosophers created science, to give us something based in reality, based in physics, to actually hold and test all of our waffle too.
Right. In other words, certain models can be useful. Start your journey of empiricism. In other words, if it was the case that the entirety of the Western world weren't deceived into believing they actually stood on a ball, they were just taught the philosophy and model and its useful applications, get a better understanding of how the motion of the stars goes through its cycles. If you conceptualize the Earth as a sphere beneath you, then you can conceptualize it with these patterns ascribed to that particular design and that particular model. That's quite useful. It lets you conceptualize it. It lets you plot it in a different way, see things in a different way. And that can be a gateway, I'm not saying it is, to finding out what those stars actually are. In other words, what I'm trying to spin is that heliocentrism, if it wasn't just told to you as your actual world reified beneath your feet as an actual sphere, it might actually lead to people doing things that were useful and did actually lead to discovery. That isn't the way it's spun. It's spun as a pathway away from opening doors, a way of doing Truman Show style, fold the map up in front of the blackboard and say it's all been discovered already. You know, and the things that we are looking into are way, way, way beyond any of your capabilities. Take this back onto spectroscopy. When QE showed the Stellar Spectroscopy Lab, that telescope, that's something that you and I could do? Is that something that we could get behind and achieve? Yeah, of course not. So out there in terms of the realms of what we could actually achieve. It's just left to them to have that pathway on the massive machines, you know, that you're not going to be getting involved in. They're just going to lead to the stories that you get told based on the models that have been reified. Not a gateway to discovery for you, the common man. It's a gate that's closed. They're gatekeeping the discovery of your nature of your reality by claiming that you've got certain aspects of it that are fundamental to your world already figured out. And a lot of them stand in violation of natural law, make no sense, use doublespeak, hijack actual studies like spectroscopy. That's a mouthful. Still on 2 minutes, QE.
No, I've been here. I've been here for the past 10 minutes. I'm just waiting till you guys tucker out. It ain't happening.
I'm gonna tucker out because seems like we're filling forever because I thought you hadn't come back.
No, I've been in here listening, man. No, it's a good discussion. Let it go. Let her budge.
Hours.
I think we covered it the other day. Comes a point where I think you accept we are created. There will be limitations to it, and for me, when we talk about the stars, I think we get to them, and that's a physicality assumption bias, Arwin, isn't it? If they're able to be got, and that's the point, are they able to be gotten to within creation? I don't see anything that points to me that you can. And I think we've got a lot of things we could do. So trying to understand something that we can't understand until we've got the means to understand seems a fruitless task to me. Past the point of understanding we already have, or what we've covered tonight is the presupposition or the assumptions we want to build into, and based on the presuppositions of what readings we've got, which we know don't mean anything, would possibly allude to. It's a fool's errand, I think, is the phrase.
Well, if you're going to go the route by indeed physicality assumption bias, then indeed it's going to be a fruitless endeavor. But who knows, the manifestation of light is still measurable. There is still more data to be gathered and to be figured out as like what's going on here, right? how does this sun really work? How intense is it? At which height and why? And is the atmosphere thickness actually like an intensifying influence on the sunlight manifestation, for example, right? These things can be figured out, and then maybe one day humanity will figure out, okay, this is exactly what's happening. That's why the celestials are manifesting the way they are because of this situation. So I am definitely one of those who think that it can be figured out, and it's all right. It's a giant puzzle, and God made it just for us.
Agree. Love to know what the sun is. And I really, really would like to know.
We know what it's not.
Yeah, we know it's not a burning ball of hydrogen in a sky vacuum.
Or a solid.
Or a solid emitting a constant spectra through a gas when you assume that you can get 90 degrees to it and see the absorption spectra. Yeah, we know it's not that either. But we don't know what it is, and that's kind of where I was alluding to feeling more dumb at the end of this process. Previously, in this context, you know what the sun is? It's a 93 million mile away ball of gas. Okay, cool. Let's get on with my day. Pancakes. Now, what the hell is that? Burning ball of gas my ass. What is it though? Because it's a pretty big part of your life, isn't it?
Well, yeah, but if, and that's what I was alluding to earlier, you accept that there is a creator, right? Then if there's a creator, we're for a purpose. And I would ask anybody out there, who on the panel thinks the purpose of you being here is to figure out what the sun is?
Not at all. No. Check it out. From spectroscopy to the meaning of existence.
Yeah.
I love it.
Yeah.
It's getting late. I get a little deep past 10 o'clock. Sorry.
Well, what could be more enlightening than figuring out what the sun is?
I didn't say that. I said, is that the point of you being here, Arwen? Is that the point of your manifestation on this plane? Is to figure out what the sun is?
No, it's not my only purpose.
I love you.
Eat, sleep.
It's a
rave.
curiosity for you. It's of no. I guarantee you, it is not your purpose. It's not my
I
purpose.
understand, but I am also
It may be a curiosity.
right. But I'm also, I don't know. I'm kind of convinced that I have the faculties to actually progress the understanding of it to a significant level. Right. So I feel kind of like, okay, I think I got these skills. I gotta do this. Like, this is God demanding me. That's why I got these skills. Right. So I think I can. I don't know if I will figure it all out in my lifetime completely, but I think I will at least help a whole lot of distance, bring a whole lot of material to work with. Right?
Let me be sarcastic with you then. And what you need is a rocket to go to space to figure it out, don't you? Oh no, we know that we don't need that. So what is it you need to figure it out?
But that's what the ballers do.
We don't know what tools we need to figure it out because we don't know what we're trying to figure out. We don't know what it is. You know, so little about it, it's untrue. But just back to your question, no, certainly not instinctually. No, instinctually, my body's saying, don't die, reproduce, and figure out what the sun is. No, it's not. Definitely not saying that to me. My body doesn't.
I agree to that. But yeah, it burns brightly. Minds. Well, it's not even that directly. It's just that's kind of like one of the prizes that might await, right? Some point of the journey. Then I could say like, yeah, man, I figured it out. Like, who could ever believe that I would? But I'm not expecting to get it, right? And I do understand I have like also earthly priorities. So
Before we go, I did want to just in case there was any confusion about the topic, I did want to not besmirch the good name of spectroscopy just because of the adulterers that took the name over. You know, just bashed it in the head, you know, and had their way with it. Spectroscopy, that is terrestrial spectroscopy, if done in a controlled environment, controls are noted, there's nothing wrong with it. It's outstanding. Okay, well, just to make
John,
sure.
Owen mentioned that. I did that. Genuinely, I could tell how much cocaine's in Nathan's urine, using spectroscopy.
Only if you got 90 degrees to the flow.
That's your twisted
or I had a cup, Nathan. That would do it. I'm not. That's the point, though, isn't it? Yeah, I would want a cup. What the good professor in the clip that John played is exactly that. Yeah, she'd be taking the spectroscopy of Nathan's urine as it flew out, rather than actually analysing it. That's about the level.
Would you stop taking the piss out of her?
Generally, though, that's a really good analogy, isn't it? It's like trying to do a urine analysis just by scanning it as it hits the bowl.
No, it gets worse than that. It's like trying to do a urine analysis from a different continent with a telescope while someone's mid-flow.
Yeah.
I'd have to say you're a twisted individual to come out with that 90 degrees from the flow. I'd have to say that was pretty darn good.
See if anybody who's joined us actually wants to add something. Scott, Farming Ganja, can you hear us? Barely in the middle of something. I did spring it on him, to be fair. What about you, Shines? Did you have something you wanted to add in terms of what we discussed, spectroscopy, or the meaning of life, if you choose?
No, I don't want to add anything because I'm out here with my 3-year-old. Super loud, but thank you for asking. Next time.
About you 3-year-old, any questions on the meaning of existence or spectroscopy? No? Moving on. Rob, did you want to add anything? Really not. Well, wasn't that nice? That's the shortest interaction from the public we've ever had ever.
Interesting, no ballers.
Ballers ain't coming.
Played a couple of times.
Ballers ain't coming close to this. They're no way.
Well, I'm still here if you need me.
Yeah.
But they've had chance, John, haven't they? You've played this a couple of times over years and recently just to put the focus on it. So they've had plenty of chance to have a rebuttal. But the queue, there's nothing in. It's interesting.
It's like a cockroach that won't die. QE summed it up at the beginning of this, right? This presentation, I've seen this presentation from 2016 through now. I've seen this presentation plenty of times. It's like a cockroach in terms of their presentation of spectroscopy as a justification for knowing what the sun is. Squash it, and then you walk away, and then 6 months later it suddenly re-emerges and starts scuttling around. You just got to squash it again. That's what this is.
The trouble with this one is it is like cockroaches. It's not one big bug. It's just tons of little, like that Spectra. There's tons of little black spots all over the place that you can't contain it because it's littered with so much contradiction. As we kept interrupting, throughout the presentation, this. But I suppose fundamentally, the gases. What do gases emit in terms of spectra? So that's the fundamental one. Me that You don't need to go any further.
You can shit can, as he puts it, the whole notion of stellar spectroscopy because it's not isolated, and they're even disclaiming that there's stuff between you and the things you're claiming to be studying. That's the briefest summary I can give in conclusion, but you have to round out at some point. Arwin, do you want to do some shout-outs for your channel and such like?
Okay. Sorry. Yeah, my channel's ARWIJN. I do a show every single day, Flat Earth Early Bird, 1 p.m. Amsterdam time in the weekdays, 2 p.m. Amsterdam time in the weekend. And I interact with my chat a lot. And yeah, I love this level of discussion. It's not always there in chat, but yeah, whatever comes, you know. And yeah, I hope to see you there. Thanks for letting me on the show again, Huey. And yeah, it's been a great conversation, guys.
Do you have any shout-outs you wanted to do, Adam?
Not for me personally, but if you'd indulge me, I'd like to give a shout out to Brian's Logic. Some good stuff. Taking a bit of flack this week. I see ballers are now producing very poorly explained videos that don't explain their point, why they have an issue with him, but call him a mong. Very interesting. So yeah, I want to give Brian's Logic a shout out. Go check his stuff. He's over the target. Ballers are just saying he's wrong. He's definitely wrong because it would work. Honestly, some very illiterate rebuttals to somebody. But the one I've seen now is about 2 minutes. He's even bothered with diagrams and the likes, but still not explain the point and address what Brian's saying, which is regards to what would happen to direction of flow. It relates a little bit what I've talked about in terms of direction of G. It's all the same thing. The world's curving away from you. If you're traveling in a straight line vector, there are implications, both in terms of direction of down, but also from aero engineering point of view and direction of airflow. Because if it is curving in a presupposed way where the atmosphere curves in its layers, and then the ground is curving away, but you're still traveling in a straight line vector, I think the ballers, maybe some others out there, maybe some of these rather embarrassing bimbo flat earthers that are out there, come out, attack other flat earthers and make an arse of themselves after attacking them. Yeah, shout out Brian's Logic. Good on you, pal.
I'll echo that, and I'll forego my shout out for myself to do a different shout out. But yeah, Brian's Logic's covering the aerodynamics and presupposition of the atmosphere thinning away. All he's getting back is a straw man. Is it a straw man? Be a straw man argument, but an argument that says, when I position the idea that it's perfectly acceptable for there not to be an issue when the ground's falling away and the air's technically thinner if I travel straight, how aren't we accelerating off to space on the airplanes, which is just a nonsensical repositioning of an argument in assumption. From Brian's Logic's point of view, he's just not getting his question answered. And he detailed this on Flat Earth Debate the other day. It'll be one of the shows that comes out over the next couple of days. But it was a great discussion between you and Brian on this subject, because initially when he explained it to me, I thought it was coming from the same point as you, and he wasn't at all. Completely new angle to it. But yeah, check out Brian's Logic. And as I say, I'll forego my shout out for Nathan Oakley 1980, subscribe today, for a shout out for Flatzoid, because he's also well over the target. You know, he's covering active, its most raw form, and he's absolutely killing it. But not just Brian's Logic, but check out Flatzoid as well. He's just ticked over 1,000 subscribers, and it's not because he has upped his game in terms of his videography, but he's just well over the target, keeping it really simple. He's better at me at keeping calm. So shout out to you, Flatzoid, and Brian's Logic. Subscribe to both of them today. Do you want to add anything, QE, before I take us home?
Yeah, take us on home, sir. Thank you.
Well, with that, a massive thank you to all of you in the live audience for tuning in, smashing the super chat, joining as a Quantum Eraser, or if you're watching this on a re-up, a Nathan Oakley 1980 channel member. Massive thank you to all of the Ballbusters panel for joining us, and the handful of people who have input from the public discussion forum that's open. So thank you to you as well. I have been Nathan Oakley, and we will see you all in the next Ballbusters.